some sports just aren't fair. Not everyone has the same chance of excelling at every sport. Some sports you want to be tall, others short, some lean, others massive. That's no surprise. But for one track and field event, the determining factor for who excels is more arbitrary than you would think. Several years ago, David Epstein wrote a book called The Sports Gene, about improvements in athletics. A big part of that story is how coaches have determined which specialized bodies are best for their sport. In many sports or events, it's just physics that determines the characteristic of the best bodies. Throwing the shot put calls for tall, massive, and strong athletes to gain better momentum and energy. Gymnasts call for shorter bodies to maximize the power-to-weight ratio for spinning and twisting. Swimming calls for long torsos and short legs to maximize the ease of moving through the water and minimizing drag, while long-distance runners call for short torsos and long legs to maximize running power and minimize dead weight. For example, even though Michael Phelps, a swimmer, and El Garouge, a distance runner, are 7 inches different in their height, they wear the same length pants. Sadly, there isn't much we can do about physics. If we want an event to see who can throw a big metal ball far, only a relatively few number of people are going to have a decent shot of being world class. However, there is one track and field event where the body type isn't determined by physics. It's determined by an arbitrary choice that a person or committee made many years ago, a choice that would forever exclude some people who could have otherwise been champions, even world class, maybe a face even on a Wheaties box, but has instead allowed others to dominate. What is that event? The high hurdles. Take a look at the lineup of the men's 2020 Olympic finals for the 100-meter sprint. Now compare them to the 110-meter hurdle finalists. One thing that jumps out is the variation in height for one and the lack of variation of height for the other. If you are fast, you can be a good sprinter. But if you're fast, you still might not be a good hurdler. Why not? Because someone, somewhere, decided that the hurdles should be a certain height and a certain distance apart, and relatively few people have the optimal body characteristics for those distances. Let's consider the distance between the hurdles. To be fast in the hurdles, an athlete needs to be able to have their natural running stride fit, so 3 steps between the hurdles ends within inches of the optimal takeoff spot. If an athlete's natural stride is too long, they have to shorten their step or stutter step, which will slow them down. If an athlete's stride is too short, they have to stretch, which will also slow them down. Notice how even halfway through this race, every runner is hitting within inches of these track marks when they plant. That doesn't happen in the flat 100. So to be an elite hurdler, your stride length has to be just right for the 3 steps between the hurdles at top speed. Now let's consider the height of the hurdles. Hurdling the barrier is different than jumping the barrier. Hurdling's more like stepping over the barrier. Notice that the hurdlers' heads don't go up, and in fact some go down when they hurdle a barrier. This is because they're trying to lift their legs over the barrier while minimizing the movement in their center of gravity so that they can snap a foot back down immediately to get back in contact with the track and accelerate. Time in the air is not time when you can be adding speed to your run. If a hurdler is too short, then they have no choice but to jump to get over the hurdle, because even going into a tight hurdle bend, they won't get their legs high enough to go over the hurdles without jumping. So to be an elite hurdler, you have to be tall enough that you don't need to jump over the hurdles, but not so tall that your natural stride won't fit the natural rhythm needed between the hurdles. We would hypothesize then that the height of elite hurdlers must fall into a narrow range of heights. To explore this hypothesis, we found the heights of 50 world-class male hurdlers, and this is the histogram of their heights. The histogram suggests that it's difficult to be an elite hurdler if they are shorter than 6 feet, or 183 centimeters. Only 4 of the 50 athletes are shorter than 6 feet, with none of them shorter than 5'9", or 175 centimeters. Only 5 were taller than 6'3", and none taller than 6'5", or 195 centimeters. But height isn't necessarily the deciding factor. We really should be analyzing stride length, or leg length. Unfortunately, that data isn't readily available, so we're using height instead since it should correlate highly with leg length and stride length. Since male athletes tend to be around the 6 feet to 6'3" range, or 183 to 190 centimeters, then that cuts out a lot of athletes from being able to compete, and even some entire countries from producing athletes that could compete in this event. Let's compare hurdlers to sprinters first. The 50 heights of our elite hurdlers have a mean of 73.28 inches, or 186 centimeters, and a standard deviation of 1.77 inches, or 4.5 centimeters. Whereas the height of 50 elite 100-meter sprinters in the world have a mean of 71.46 inches, or 181.5 centimeters, and a standard deviation of 2.68 inches, or 6.8 centimeters. Assuming that the heights of these elite athletes are normally distributed, here are what those distributions look like compared to the US male height distribution. The US male height distribution has a mean of 69 inches, or 175 centimeters, and a standard deviation of 3 inches, or 7.6 centimeters. We are using the United States in this week's video, whose heights distribution is similar to many other European countries, but we will look at other countries in our video for next week. Here's something to notice. The shortest height of an elite hurdler is the average height of a US male. The average height of an elite hurdler, 73.3 inches, or 186 centimeters, is almost 1.5 standard deviations above the average US male height. About 90% of the heights of elite hurdlers fell between 6 feet and 6 feet 4 inches. Using this normal distribution calculator, we find that only about 15% of US males are in this optimal range for hurdling. Competing in the flat 100-meter sprint pulls about 90% of elite athletes from 5 feet 8 to 6 foot 3, or 172 to 190 centimeters, at least according to our sample, and about 62% of US males fall in this range. Is there a similar story in the women's hurdles? Let's compare the same three distributions. This is the distribution of heights of 50 world-class female hurdlers, and this is the distribution of heights of 50 world-class female sprinters in the 100-meter, and this is the distribution of heights of US adult females. There's a different story here than with the males. There's not as much separation between these three distributions. Hurdlers are still taller than sprinters, and sprinters are taller on average than the population as a whole, but there's a lot more overlap. 90% of our elite hurdlers were in the range of 63 to 70 inches, or 160 to 178 centimeters. About 57% of US females fall into this range, much larger than the 15% for men. So why aren't elite female hurdlers so much taller than the average female height, like with the men? There could be two culprits: the distance between the hurdles, or the height of the hurdles themselves. It's hard to know how to analyze the effect the length between hurdles has on the height or stride length of the hurdlers. If you have ideas, put them in the comments, please. One first step is to look at the ratio relationship between the distance between hurdles and the average elite hurdler height. The average height of an elite male hurdler is 73.3 inches, and for the men's high hurdle race, the distance between hurdles is 30 feet, or 9.14 meters. That's a ratio of 4.91. Or it takes 4.91 average hurdlers lying down end to end to stretch from hurdle to hurdle. On the women's side, the ratio of average elite hurdler height and the distance between hurdles is 5.03. Surprisingly close. So nothing dramatic here that might point to why there's a larger spread in the distribution of heights for women than men. Let's look at the height of the hurdles next. With men's high hurdles standing at 42 inches, or 106.7 centimeters, that puts the hurdle height at more than 60% of the height of the average US male. For women, the high hurdles are 33 inches, or 83.8 centimeters, so the hurdles are about 52% of the height of the average female, quite a bit lower than the men. This means females can be shorter and still hurdle rather than jump the barriers during the race. You can see by comparing the men's and women's Olympic finals from Tokyo that the women, especially the tall ones, do not need to bend their bodies much to go over the hurdles, but the men are extremely bent over when they hurdle, almost hitting their knee with their chin. So what could we do to make the hurdles a sport that more people, especially males, could excel at? We will share our ideas, but if you have ideas on how to open up the hurdles to even more competitors, put them in the comments. Or if you know of other sports where an arbitrary rule changes who can be competitive in the sport, put that in the comments as well. Here are some of our own ideas. We could lower the hurdle height for men so shorter people could compete. That might make it more like the women's race where it's not so exclusive. We could also have 3 high hurdle races, one at 110 meters with the current hurdle height, one at 105 hurdles with shorter hurdles, and one at 100 meters with even shorter hurdles. Then almost anyone could have a race that would fit their height. Another strategy is to change the rules. Why do we have to have the hurdles all at the same position on the track? Other events allow some flexibility. For example, long jumpers and high jumpers don't have to start all at the same spot. Pole vaulters can start at a different position, and they can even adjust the position of the bar relative to the pit. Why can't hurdlers adjust the hurdles like pole vaulters, within some minimum and maximum distance? This would allow some people to be competitive in an event that's arbitrarily stacked against them. Now, do we really think that the governing board of international athletic competitions will take these seriously? No, of course not. They might actually counter with the fact that there are other sports and events, some of which give smaller bodies a better advantage, like diving and gymnastics. No one's being forced to just do the hurdles. But what we have learned is that it can be to your advantage to pick a sport that plays to your body type. But if you're not a perfect fit for a sport you enjoy, don't fret about it. Keep doing what you enjoy. We can learn a lot from the women in the 100-meter hurdles in this instance. The last Olympic gold medalist was Jasmine Camacho Quinn at 5'8" or 173 centimeters. But there were only 2 hurdlers in our list of 50 that came in at the shortest, 5'1" or 155 centimeters, both 2 inches shorter than the next hurdlers in our sample. One of them took 3rd in the Olympics, earning the Olympic bronze medal. That was Megan Tapper from Jamaica. And the other still made the Olympic final and later broke the world record. That was Toby Amison from Nigeria, who now has claim to the title of the best hurdler ever. Thank you for watching. Please subscribe and share our videos. Be sure to follow Math the World on Twitter, Instagram, and Facebook. Thank you so much for your support.